Hello, ladies and gentlemen. We are going to be looking at the signature lab for Unit 1, which is the flame test. So the purpose of this lab is for you to observe the characteristic colors produced by certain metallic ions when they're heated in a flame, and also to identify unknown metallic ions based on their flame test results. So a flame test is a qualitative analytical technique used to identify the presence of certain metal ions. So we've talked about ions in class, and we know that ions are charged particles, okay, because they're either losing or they're gaining electrons. Now, because we're talking about metal ions, they're actually going to be positively charged particles. So when our metal ion is heated in a flame, its electrons absorb energy and jump to a higher energy level. That's the same thing as an excited state. As the electrons return to their ground state, they release energy in the form of light. The color of this emitted light is unique to each metal ion, allowing for its identification. Okay, so this here just goes over the safety protocol, which either myself or your teacher will be going over in class before you do the lab. So let's look at the pre-lab questions. So the first question is, what is the primary purpose of conducting a flame test? Okay, so as mentioned in the introduction, we want to identify the presence of certain metal ions, which we said were charged particles. So that's the only reason we would do a flame test. Now this question here, go ahead and just skip it. It's not worded correctly, so don't worry about that one. Okay, for question 3, it says, what causes the characteristic color emission during a flame test? So when you see the word emission, just think like given off. So when we're seeing this color emission, these are the colors that are given off. So as stated in the introduction, this was talking about what happens when we put our metal ion in the flame test. So the first step is that the electrons have to absorb energy. And when they do, they then jump to that higher energy level. And we don't see any color until the electrons return to their ground state. That's when they release energy in the form of light. So your answer for question 3 needs to be very specific, and it needs to be talking about how we see the color when the electron returns back to the ground state. It's releasing energy as light. A lot of students will put that they see the color because the electrons are in the excited state, and that is not the correct answer. They're in the excited state because they are absorbing that energy. They need to give off the energy, and that's what they do by giving it off as light, and they don't do that so they return to the ground state. All right, number 4, what happens to electrons and metal ions when they are heated in a flame? So we just explained that process. So it's like a 3-step process. They absorb the energy, and then they jump to the outer energy levels. And then the third part would be they return back to the ground state, and that's when we see the colors. So we can even add that in as the third step. So this is the first step. This is the second step, is when they jump to outer energy levels. And then the third step would be they return back to the ground state and release energy as seen by the light. Okay. All right, and then this picture here, this is going to have us look at this diagram, and we're trying to figure out what's going on in 1, 2, 3, and 4. So we talked about this a lot already in questions 3 and 4. So this is the very first step in which we see energies being absorbed. Okay, so the electrons absorbing that energy. In step 2, electrons are jumping to the excited state, so they're leaving that ground state and going to an energy level that's further away. In step 3, they're going to return back down to their rested ground state. And then in the process, we're going to be releasing energy in the form of light. And another word for that is photon. Okay, so that's a particle of light. That's a photon. Okay, and then questions 6 and 7, those are just going over lab safety. So what's the primary purpose of wearing your safety goggles and apron? It's to protect your clothes and eyes. And then what should you do with your hair and any loose clothing? You want to make sure that it's tied up so you have nothing dangling. All right, we're going to go ahead and flip over, and let's go ahead and get our data table set up so that we can be ready to go for the lab. Okay, so on this part, you do have to fill in this data table, and the compound name is given to you, and what you're asked to do is to write down the formula. Now, we have not gone into formula writing yet, and we will be doing that later on. So for now, I'm just going to be showing you a quick little trick. So when we have our compound name here as sodium chloride, sodium is on the periodic table, and it's right here, element number 11. So if I find sodium and I look all the way at the top, I can see it's a +1 charge. So that's why I took my pencil and I wrote in +1 above my sodium. Chlorine is all the way on the right side because it's a nonmetal. So if I look all the way up at the top, I have a -1 charge. So that's why I wrote +1 and -1. So to figure out my formula, I really just need to do my crisscross charge. So I'm going to take my +1 and -1 and just crisscross them. And when I do that, I get NaCl as my formula because I only have one Na and I have one Cl. Now, how did I know that my metal ion was +1? Because the metal is always written first in my formula and also in my name. So this is what we're looking at when we do our flame test. We're looking to see what color that sodium ion is going to be. All right, now we're on to the next one, which is calcium chloride. So I got my calcium +2 by looking at my periodic table. There's calcium. I look all the way at the top. There's my +2. So that's why I put a +2 above it. And then chlorine is the same all the way down. So I know chlorine is going to be -1. So if I flip those two numbers there, my formula is going to be calcium chloride with a +2 calcium ion. All right, and calcium is my metal. That's why it's written first. All right, let's try potassium chloride. So potassium, if you find it on your periodic table, it's element 19, and that's a +1 charge. Chlorine's a -1 charge. So I'm just going to write the symbols, and I'm going to put it together to get KCl. And then my potassium ion is K +1. All right, let's do strontium chloride. So strontium is +2. I know that by looking at my periodic table. There's strontium. I go all the way to the top. It's +2. So strontium's +2, chlorine's -1. So when I crisscross them, I get SrCl2. And my ion is strontium with a +2 charge. All right, I'm just going to show you the answers for the rest of them. Hopefully you're seeing some sort of a pattern there in terms of how we're figuring out these formulas. Don't feel bad if you aren't following along quite yet. Like I said, we are going to be going into this in Unit 3 and more so in Unit 2, but it's nice just to get a little appetizer of what's to come. All right, ladies and gentlemen, so you should have this much filled out. In lab, you are going to be figuring out what the color is for each of these metal ions, in addition to what the wavelength should be, so that you can figure out your color from the video. I'm just going to show you the first example just so you get an idea of what you're going to be doing. But if I watch the video, it's going to show me that sodium has an orange flame. So then I'm going to go to my data table up here, and I'm going to find orange, which is, let's see here. Why did I put orange here and then 590? So if I look at sodium, it's showing it's orange. So if I come up here, an orange should be 625. So I'm going to write 625, and that is how I got the wavelength, because every color has a specific wavelength. All right,